Alright, this video is on 5.3, which is going to be solving polynomial equations. So remember that polynomial equations just have like cubes and squares and fourth powers and stuff. And if we're going to, we already know how to solve first power ones, right? Like 2x plus 1 equals 11. You can just use your algebra steps, solve that, whatever. But we're going to do now exponents greater than 2. Okay, and the way we're going to do this is factoring. So this section, there's a whole bunch of different lessons and videos, and probably takes 3 or 4 days. And the reason is there's so many different ways to factor. All right, and so just as a reminder what factor means, right? You could pause the video and try and remember, right? But if you don't, what factor means is just to break apart. So with a regular number like 20, you can factor it into like 2 times 10, and then break 10 apart into 2 times 5. So that's called factoring, to break apart. And with a polynomial like this, you factor it, like one of the ways is like a GCF. So like this one has a GCF that you can pull out to the front. Okay, and then you just keep going factoring from there, right? This might factor, I don't know, but could factor, whatever. And we'll do some more examples and it'll make more sense, but we want to break it down. Okay, and so before we dive too far into this, this slide right here is it. This is the entire lesson conceptually, right? Again, there'll be a lot of different ways to factor, but the concept is when you solve equations, right? These are different polynomials, first degree, second, third. We just slowly build complexity, right? We'll do fourth degree and all that stuff. But the idea is a linear one, you just use your algebra steps. So that's like what you've done forever, right? And I call that algebra steps, where you do the opposite operation to get x alone. Okay, when you hit higher level, the way we're going to do this, or one of the ways to solve a quadratic, at least the factoring route, is to break it down into linear and then use our algebra steps, right? So for this particular one, we could factor it, right? And we'd say what multiplies to 12 and adds to 7. So we do x and x in our little binomials. So it would be x plus 3 and x plus 4. Multiply to 12, add to 7. All right, and then we set each of these to 0. Okay, and so this is the important part to me. Sorry, miswrote there. Is once you get here, you actually have two linear problems, right? We broke this in, we took an x squared and broke it into 2x to the first, right? And now that we're the 2x to the first, you can just solve them like you did before with algebra steps. Minus 3 from both sides, that gets you one answer. Minus 4 from both sides, that gets you another answer. All right, so that's the idea, is you break it down into smaller chunks and then solve those with the methods that you know, right? So what we're going to start doing now is take the cubic and we're going to try and break it down to quadratic or linear, right? Because we already know how to solve quadratics, right? So we did that in the previous chapter. So we can factor, right? So once you get to quadratics, remember your methods are, sometimes you can do algebra steps if it has just x squared in it and no x. You can factor like I did in the example above to solve it. There's the quad formula, right? You can always solve a quadratic with any x squared with the quad formula. And then there's also that graph method where you graph and find the x-intercepts. So the idea is if we have an x cubed, as long as we can break it down to linear and quadratic, we already know how to solve those. So we just have to break it apart, right? So with this factor method, we'll do this example right here. It should be on the note sheet, or again, if you just want to write this down in your regular notes as an example. If you don't have a note sheet, you can just write it in notebook paper. But we're going to solve by factoring. And again, there's a lot of different ways to factor, but this one has a GCF. So we're going to pull out that GCF first. Okay, and then technically we could stop here because we would have one answer of 0. That times x generates an answer of 0. If x is 0, then 0 times whatever this is will be 0. And then we could solve the rest of this with any method we want, right? This x squared, we could use any of our methods down here, right? But for this example, it's probably just going to factor, right? So it looks pretty easy, and we should at least try to factor because we talked about before, factor is one of the faster methods. Like we could do quad formula, but that takes a lot of time. So let's see if we can factor it quick. So to get the x squared, again, we use x and x. And then we need one positive and one negative. If we have negative 3, So it looks like it'd be -1 and +3. That would multiply -3 and add to +2. Right, so we had the one answer here, 0, and now that these are broken into linear, we can set each little linear part to 0, and we'll get 2 more answers. Right, so this one would be x equals 1, and x equals -3. Okay, so hopefully you got this info down in your notes. I would actually probably take all of this and have it written down. And again, the key is you want to break it down. You want to factor the cubes down into smaller pieces because we already know how to solve those. All right, so if you didn't get all this, you can pause it, take some notes here quick, or hopefully it's on the note sheet too. So here's the general process when you have an exponent that's higher than 2. For right now, what we're going to do is get the 0 on one side, check for the GCF. So when you're factoring, check GCF first. And then from there, keep factoring until you either have x or x squared, and then solve those parts, right? Set them to 0, solve the little parts and set them by setting them to 0, and then solve them individually, right? Because again, we already know how to solve linear, and we already know how to solve any quadratic. If nothing else, you can always use quadratic formula. If you have an x squared and you're stuck, use quad formula and you should be able to solve it. So some more examples. And one of the things you're going to start to learn in this chapter too is that the exponent will derive the number of solutions. So when you did linear, that had 1 solution. When we did x squared, that had 2. This one will have 3. And then eventually we'll start doing x to the 4th that have 4 answers. So pause the video and give this one a shot. All right, referencing the notes from the previous slide, we want to get 0 on one side. So we can add 16x to both sides. Now we got equals 0. Okay, and then now take out a GCF. So there won't always be a GCF, but there is on this one. So you can pull out a 2 and an x, which leaves us with x squared plus 2x plus 8. Sorry about my phone going off. And then I would try and keep factoring. So let's see, this thing we could say 1 multiplies to 8 and adds up to 2. So we have 1 and 8, 2 and 4. But it has to be 2 positive numbers, and none of them are going to add up to 2. So it looks like this does not factor. So now we got to solve the parts, right? So we're going to set this part to 0 and set the x squared to 0. Okay, and then this one's pretty straightforward. Just divide by 2, and 0 divided by, 2, no, 0 divided by 2 is 2. Okay, and then this guy, since it doesn't factor anymore, we could go with the graph method if you like that on your calculator. But since I don't have a graphing calculator handy, I'm just going to do quad formula, right? And I'll throw that formula up here. Okay, so we got our little quad formula here, and so we're going to take the coefficients. A is 1 out here, B is 2, and then constant C is 8. Now I always do this part of the formula first, since that takes most of the work anyway. So I'm just going to do b squared minus 4 times A times C. 4 minus 32, negative 28. So that maybe shows why we can't factor it, because these are going to have imaginary answers. So I'm going to have root negative 28. I'm going to do simplest radical form. 4 divides 28 evenly as a perfect square. And I'm also going to pull off the negative so that the 4 becomes 2, square root of negative 1 becomes I, and then we have root 7. So my answers here are going to be 2 imaginary answers. So x is going to be opposite of b, plus or minus all that stuff I just cleaned up. So 2I square root 7. And divide that all by 2a. So that's just going to be 2. Okay, and it looks like that does divide out evenly too. So you could also write it as negative 1 plus or minus I root 7. Okay, and that would be our other 2 answers. So this x cubed had 3 answers, one real one here, and then a pair of two imaginary answers down there. All right, so our goal is to find all the answers, real and imaginary, and we ended up with 3 on this one. All right, getting a little bit trickier. This one's an x to the 4th. So again, pause the video and see if you can find how many of the 4 answers can you find. Already got 0 on one side. So from there, we're going to factor as much as we can. We need to get it at least to x squareds and x to the 1st, because you know how to solve those. So GCF is a 3 and x squared. I'm going to pull that out, leaving us with x squared plus 5x minus 10. Okay, and then I'm going to see, does this factor anymore, right? If it does factor, it'll be pretty easy. So let's see, negative 10. We have negative 1 and 10, and negative 2 and 5. So again, that one looks like it doesn't factor anymore. All right, so we could do quad formula like we did in the last one. We could also try graph. Right, maybe I'll try graph just to do something different on this one with you. So we do have it down to x squared, so we can solve like this one, 3x squared equals 0. We can actually use algebra steps here because we have just x squared. So we're going to divide both sides by 3. And 0 divided by 3 is still 0. And then when I take the square root, this is a little bit goofy part, but normally when you do a square root, you get 2 answers. You get plus minus. So here we're going to write plus minus 0, and it's really just 0 twice. But that does matter because we want to have 4 answers. So this is going to be a multiplicity of 2. It's like a double answer. That 0 counts twice. All right, so let's try graphing this other one and see if we can find any real answers that way. Okay, so I got my handy graphing calculator here. So I'm just going to go into y equals, clear out anything that's in there. And I believe it was x squared plus 5x minus 10. And then I graph. So this does have real answers, right? So looking at this, it does cross here and here. So I can actually just remember your answers are your x-intercept answers. So yeah, we can probably just estimate here. This is about, I don't know, 1.6. And this one's going to be negative, geez, I don't even know, 1, 2, 3, 4, 5, 6. And maybe I'll do this. I'm going to hit trace once on here. And this will give you a little bit better picture. So this one, we'll call that, no, it looks like 1.5. I'm just hitting the over arrow here. Remember, there's a way to do this if you want a more precise answer, but I'm just doing an estimate here. It's taking a little bit of a while to get there. And about negative 6.5. So for our purposes, that's close enough. All right, so we used a calculator to get our other 2 answers, and they were x equals 1.5 and x equals negative 6.5. And certainly we could have used quad formula if we want, but just to show you a different method, that's the graph method to get 2 more answers. All right, I think the note sheet has one more for you to try here. So if you want to give this one a shot, and then unpause this video and see where you're at. If you can get this, you should be in good shape. Okay, so we know this one should have 3 answers because it's an x cubed. Get 0 on one side, so minus 15x. Pull out an x. Sorry, that'd be an x squared there. That's our GCF. And now I think I made this one factor, so it ends up being easier where I could again solve this x squared with the quad formula or the graph method or something, but if we use x and x here and negative 15, I think 3 and negative 5 will give us negative 2. We use a plus 3 and a minus 5, right? And then now we're good because we have one answer of x equals 0 from the times x, and then set the other 2 to 0. Okay, and we get x equals negative 3 and x equals 5. So again, the whole idea of this is we want to break it down, right? So we started with an x cubed and we broke it into 3 little linear factors right here, and then we could solve those with our old method for linear, which is just algebra steps, right? And we're going to do that more in the next couple lessons here, but all that's different is the way you factor, right? This was all GCF factoring and this kind of basic factoring here, and we're going to learn some more advanced types of factoring.